for my next trick, we're going to use this idea of power series to write a repeating decimal as a fraction. And you can use this to turn any repeating decimal into a fraction. The way it's going to work is we're going to turn it into a geometric series first, and then write it in sigma notation. And then we'll use the formula for the sum of an infinite geometric series, which is a fraction a1 over 1 minus r. And we're going to turn that, look at that fraction, and we're going to see what fraction 0.345 is equal to. So if I write this as a geometric series, it is 0.345 plus 0.000345 plus 0.000000345. If my repeating pattern is 3 digits long, then every time I add another term, I need 3 extra zeros in front of it. So first there's no zeros, then 3 zeros, then 6 zeros. Next one will be 9 zeros, and then 3, 4, 5, and so on, and so on, and so on. Which is, in other words, 0.345 times 1 over 1,000. And the next one would be 0.345 times 1 over 1,000 squared. Every time I add another term, the next term I'm adding, the next smaller digit, decimal, is just 3 decimal places smaller, which is multiplied by 1 over 1,000. So if I think of that in sigma notation, it is 0.345 times 1 over 1,000 to the nth. So in this case, the A1 is 0.345, which, it'll help us in a second to do this, is 345 over 1,000. And the R is 1 over 1,000. So using the formula for the infinite geometric series, A1 over 1 minus R, that is 345 over 1,000 over 1 minus R. Saying over 1 minus r is the same as adding the factor 1 minus r to the denominator. 1 minus 1 over 1,000. And we could write this as, we could distribute that denominator 1,000 minus 1. So that would be 345 over 999. And so that is 0.345 repeating. Cool trick we can do with this, I'm going to look at number 3. Not sure why they were out of order to begin with. So we can do this for this one also. It's the same idea. If we look at what we have here, the first digit is 0.9, and then next 0.09, and then 0.009. So you can see the pattern here. We're starting with 0.9, and then every time we're multiplying that 0.9 times another tenth. Because we're adding 1 0 in front of it. And here, for the third term, we'll have added 2 zeros. That's 1/10 squared. And so our sum here is starting with 0.9 times our common ratio to the nth power. So that 0.9 is our A1, and the common ratio is 1/10. And remember, 0.9 is 9/10. So our infinite sum would be A1 over 1 minus r, which is equal to 9 over, distribute that 10 minus 1 is 9. So this is proof that 0.9 repeating is equal to